Hello class, today we're going to talk about section 10.3, completing the square. We have two learning objectives today. We are going to form a perfect square trinomial from a given quadratic binomial. Now hopefully you remember this term, perfect square trinomial. We talked about how to factor perfect square trinomials back in chapter 9. Today I'm going to show you how we can use perfect square trinomials. Second, we're going to write a given quadratic function in vertex form. Just one vocab, completing the square. Let's get to work. So first, the idea of completing the square. So to make a perfect square trinomial, all right? The idea behind completing the square, the whole reason we complete the square is to create a perfect square trinomial. You may remember, again, back in chapter 9, when we were factoring perfect square trinomials, now we're going to create perfect square trinomials because they are easy to factor. So what we do, if we have some quadratic binomial like this, we are going to want to complete the square. We complete the square by adding this third term. How we find that third term is we take our b value, we divide it by 2, and we square it. Alright? So in here, b divided by 2 squared. Let me show you a real example of this. So let's say we have this quadratic binomial, x squared minus 10x, and they want me to complete the square. In order to complete the square, I'm going to add a third term. This will create a perfect square trinomial. Okay, again, trinomial means there's 3 terms. In order to find the blue term here that creates the perfect square trinomial, what I need to do is I take my middle term, in this case a negative 10, I divide it by 2, and I square it. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So 25 completes the square. X squared minus 10x plus 25 is a perfect square trinomial. You don't believe me? Do the test. Square root of the first term is x. Square root of the last term is 5. 5 times x, and doubled that gives me 10x, that middle term. So this is a perfect square trinomial. Now, what we're going to be doing with this perfect square trinomial is we are then going to factor that perfect square trinomial. So we take the square root of the first term, square root of x squared is x, we put it here. Take the square root of the last term, square root of 25 is 5, we put that here. And we steal the sign in the middle and square it. So the whole point here is this is a perfect square trinomial that I created by completing the square, and that factors down to this. So we completed the square, and then we factored. Now, it may not always be a perfect square or a nice number like this. Let's say we have this, for instance. X squared plus 5x. So again, I would like to complete the square, okay? We are going to complete the square. So we do the same thing we just did. We take our middle term 5, we divide it by 2, and we square it. Now here's the thing. We can do 5 divided by 2 and get, 2.5 and then square 2.5 and deal with decimals. But honestly, I think it's easier to just leave it as a fraction. Here's what I mean. So 5 over 2 squared simplifies to 5 squared over 2 squared, which gives me 25 over 4. So the number that completes my square here would be 25 over 4. Now, you may be asking, why is that any easier than using a decimal? And let me show you why. When we go to then factor this, again, we take the square root of the first term, then we take the square root of that last term. Now, the square root of 25 over 4 is equal to the square root of 25 over the square root of 4, or how we can write that, 5 over 2. So the square root of 25 over 4 can be simply written as 5 over 2. And I think that's easier than taking square roots of decimals and things like that. In the long run, we're going to want to be able to work with this with fractions, so I recommend you practice that now. All right? And then our final 2 steps, we steal this sign and we square it. So this was completing the square, and this was factoring that perfect square trinomial. All right, so how can we use this? So I just showed you how to complete the square. I showed you after you got that perfect square trinomial, how to factor that perfect square trinomial. But how could we ever use this? Let me show you. We are going to be writing quadratic equations that are in standard form, and we'll be rewriting them into vertex form. Now they go through all these steps. I'm going to summarize this a little more in my own example. So here's what we're going to do. We are going to rewrite y is equal to x squared minus 8x plus 7 into vertex form. Let's do that. Now hopefully you remember vertex form from section 10.1. In fact, there it is, okay? Vertex form is y is equal to a times the quantity x minus h squared plus k. It's very helpful because we can easily pick off the vertex of a quadratic function, okay? So that makes things a little easier. So let's go ahead and rewrite that problem we just had. So we had y is equal to x squared minus 8x plus 7. All right? That is a quadratic function, and that's a quadratic function written in standard form. Written in standard form. Our goal is to rewrite this quadratic function in standard form in vertex form. Y is equal to a times the quantity x minus h squared plus k. And what's nice about rewriting this into vertex form is we'll be able to easily find the vertex. Now, in order to do this, we have a couple steps. Let's get started. First thing we need to do, so we have y is equal to x squared minus 8x. What I want to do here is just write plus blank. That's where we're going to complete the square, okay? That's where we're going to complete the square. Then that 7 on the outside, let's just move that here. So what we're going to really focus on is creating a perfect square trinomial. Now, here's the thing. We do have the golden rule of equations, by the way. If I do something to one side of the equation, in order to keep that equation balanced, I better do it to the other side as well. So we need to add that same blue value on the left side of the equation as well. So far, I haven't done anything. All I've done is given myself space to complete the square. So let's go ahead and do that. Let's complete the square. So the first thing we're going to do, complete the square. Cool, let's do it. So we take our middle value again, negative 8. We are going to divide it by 2 and square it. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So I put 16 here, and I put 16 here. And what I have done now is I have created a perfect square trinomial. Great. So let's rewrite that. I'm going to just rewrite my equation. I'm not going to make any changes right here. I'm just going to rewrite just to make it a little neater. So, yeah, we should be fine. 16 plus y is equal to x squared minus 8x plus 16. That's my perfect square trinomial. We really like to have that. Plus 7. Now, if we look down at our end goal, okay, we have this x minus h squared. The only thing that we can factor that gives us a binomial squared is a perfect square trinomial. And that's why we create a perfect square trinomial right there. So what we're going to do next is we are going to take that perfect square trinomial and we are going to factor that perfect square trinomial. Let's do it. So we still have 16 plus y over here. We need to factor our perfect square trinomial and then plus 7. So let's factor that perfect square trinomial. Hopefully you remember how to do this. Okay, again, this is from chapter 9. We take the square root of the first term, we put that here. We take the square root of the last term, we put that here. We steal the sign in the middle, and we square it. So what this is telling me is x squared minus 8x plus 16 is equal to x minus 4 squared. And the reason I wrote it as x minus 4 squared is so I have a binomial squared, just like we do in vertex form. Now, what you should see is we are very close to our end goal. The only difference between where we are right now and our end goal is the fact that y is not alone over here. So our last step is solve for y. Let's do it. So we are going to subtract 16 from both sides of the equation, giving me y is equal to x minus 4 squared minus 9. And as you can see, this is in vertex form, okay? My a value is 1. Again, it's just hidden, okay? Just a little side note. Anytime we complete the square this year in freshman algebra, this a value will always be 1. In a couple of years, we'll learn how to complete the square when that a value is not 1, all right? But for now, we'll just forget about that. My h value here is 4. It looks like negative 4, but again, h is a liar, okay? And my k value is negative 9. So, what we can say here is we now have our equation written in vertex form. Let's write that here. And I can say that my vertex would be 4, negative 9. So, what we did there is we took a quadratic function in standard form. We first completed the square, then we factored, then we solved for y, and we are left with a quadratic function in vertex form. If you were to graph this and graph this, they would be identical. All right? So that is how we convert from quadratic function in standard form into vertex form. So, that's section 10.3, completing the square. We're going to do plenty of practice with this, okay? 10.3 is a little tougher to pick up, so we'll do plenty of practice. Our two learning targets today, first we formed a perfect square trinomial from a given quadratic binomial. We did that by completing the square. And second, we wrote a given quadratic function that was in standard form into vertex form. And that was that whole process we just went through. That's section 10.3. Have a great day.